So the focus of this thing was producing oil and gas has become ever more resource intensive in terms of just energy put in to get energy out. And a lot of that often has environmental impacts, either directly in energy consumption and emissions from that, processing byproducts. Meanwhile, there's been some really interesting advances, and they're continuing in the materials science space, nanomaterials, nanoparticles in particular. The question became, what can we do with the material science advances, which are happening completely independently of anything going on in fossil fuel production? Can we bring what's happening there to bear on the question of, can we reduce the resource intensity for continuing to produce hydrocarbons, especially in places like Alberta, where the resource is huge, the opportunities are huge, and correspondingly, the impacts will be huge. There's a spirit of innovation, of entrepreneurship in Calgary, in Alberta, certainly at this university. I became immersed in this idea of how startups can have impact based on deep tech, hard tech. What started happening was just a whole series, I quit counting after about 24, of invention disclosures, several of which moved on towards patents, and some of those were picked up as the foundation for some startups. That was something that we hadn't planned on, but it became the focus for a while, and pretty successful. So I knew that life is everywhere on this planet, and most of that is in the form of microbes. They have figured out a whole lot of ways to interact with other forms of matter on this planet. We have the opportunity to explore this a lot. You can get a microbe, introduce appropriate nutrients under appropriate conditions, and that was what a lot of the work here was about, such that they will generate the nanoparticle and it will stay attached to the outer surface of the microbe. What this does is give the microbe a new capability. It gives it a superpower. This could be helpful in other things like mitigating microbially induced corrosion, which is a big deal in pipelines. So if there's other ways to inhibit those guys get established inside a pipeline, one could harness this mechanism to selectively to stop them from doing what they're doing and keep the pipeline from leaking. The infrastructure that we've built here that will carry on isn't just the space and the instruments, it's the people who have worked in the way I've just been talking about with innovation and discovery and so forth, working with a variety of disciplines, all in the same, rubbing elbows. But the other people I'm thinking of are the postdocs, the research associates who have gone on. It has changed their lives, frankly. They've had an experience here that allowed them to realize, oh, I can go do things. That is so satisfying. If you can enable people to do things, to have impacts, to find their joy in terms of the professional opportunities, that's pretty cool. And that's one of the great things about being in academia is you get that opportunity to encourage, to foster, to enable the next generation to go out there and have impacts. And so that's I think is going to be the most enduring part of what's been done here. Future of energy at UCalgary. It's going to be diverse. It's going to be informed both by the need to sustain what the global economy is currently built on, but to do that in a more environmentally responsible way and help usher in the whole raft of alternatives. What I think this university can really do is bring together a broader section of scholars on campus to answer the big questions about energy and its role in society.